Welcome to the DIY Honda Garage channel. In this presentation, we will delve into the details surrounding DTC P0131, which indicates a circuit low voltage in the air-fuel ratio AF sensor or sensor 1. The AF sensor is essential for adjusting the engine's air-fuel mixture, thereby optimizing performance and emissions. When the sensor output voltage is below the prescribed value, the Powertrain Control Module, PCM, flags it as a fault, storing the Diagnostic Trouble Code. This code commonly appears when there are issues with the AF sensor itself, the wiring that connects it, or the PCM. Understanding the functions of the AF sensor and its layout in the vehicle sensitizes us to how faults arise and affect the engine's operation. Hence, efficient troubleshooting demands a systematic examination of these components and their connections. DTC P0131 designates a low-voltage output from the air-fuel ratio AF sensor known as sensor 1, which directly influences the engine's fuel-air mixture. The AF sensor measures the concentration of oxygen in the exhaust gases, sending an electrical signal to the Powertrain Control Module, PCM. The PCM, located in the engine compartment, interprets this data to optimize fuel combustion. Sensor 1 is typically positioned upstream of the catalytic converter, making it crucial for ensuring efficient engine operation. Any malfunction in the sensor or related components could lead to suboptimal engine performance and increased emissions. The precise location and operation of the AF sensor are fundamental for diagnosing the root cause of the DTC effectively. Several factors can lead to the triggering of DTC P0131. One primary suspect is a faulty AF sensor, sensor 1, which may be unable to provide accurate voltage readings due to internal malfunctions. Additionally, damaged wiring or short circuits in the sensor's connection can cause false readings, leading the PCM to incorrectly assess the sensor's signal. Furthermore, if the PCM itself suffers a failure, it may not interpret the data from the AF sensor correctly, resulting in stored trouble codes. Each of these potential causes requires thorough investigation to ensure effective resolution. Identifying the specific reason for the error helps avoid unnecessary part replacements and associated costs. When DTC P0131 is present, drivers may experience several symptoms related to the engine performance and efficiency. One noticeable sign is reduced engine performance, which can manifest as sluggish acceleration or poor responsiveness when driving. Additionally, an increase in fuel consumption is often observed as the engine struggles to maintain the optimal air-fuel mixture for efficient combustion. Another critical indicator is the activation of the check engine light, which warns the driver of potential engine management system issues. These symptoms are not just annoying, but can also lead to more severe engine issues if left unaddressed. Hence, recognizing these warning signs plays an essential role in timely maintenance. The first step in troubleshooting DTC P0131 involves starting the engine and bringing the RPMs up to 3,000 while in neutral. This process helps simulate operational conditions to check if the AFAC sensor operates under load. It's crucial to hold the engine speed at this level until the radiator fan engages. Once the fan kicks in, it indicates that the engine has reached the right temperature, ensuring the sensor should be sending accurate readings. After observing these conditions, letting the engine return to idle allows for assessing the sensor's voltage output. Following this procedure accurately is vital for diagnosing potential problems in real-time conditions. The second step requires an in-depth inspection of the AF sensor, labeled as sensor 1, and checking its corresponding 6P connector. It's essential first to disconnect the AF sensor from its harness to ensure safe inspection. Once disconnected, a continuity test is performed to verify the internal circuitry of the sensor. For the inspection, certain readings should be taken to confirm that they are not shorted. For instance, each terminal should indicate a status of off when examined for continuity. If any of these readings deviate from expected norms, it indicates an internal fault with the AF sensor itself. Proper execution of this step is imperative for isolating faults related to erroneous voltage readings. The third troubleshooting step focuses on examining the wiring circuit connected to the AF sensor. This involves checking for any shorted wires that may impact the sensor's ability to send correct voltage signals to the PCM. During this inspection, technicians will typically jump the service check switch, SCS, with the Honda Diagnostic System, HDS, to initiate the testing process effectively. Once secured, the resistance across the wires such as LAF-VG, LAF-VN, LAF-CP, and LAF-CA should be checked, ensuring that each in-ground inspection shows more than 1 mega-ohm, confirming no short circuit conditions exist. This step is crucial to avoid overlooking potential wiring faults that could mislead the diagnosis. The final step in troubleshooting DTC P0131 involves a thorough inspection of the powertrain control module, PCM, itself. After confirming that both the AF sensor and its wiring are functioning correctly, the focus can then shift to the PCM as the potential source of the issue. This step requires employing advanced diagnostic tools to check the PCM for proper operation and communication with the AF sensor. If previous checks have indicated that both the sensor and wiring are operating within normal parameters, and the PCM is found lacking, it is likely the cause of the DTC. Effectively verifying the PCM functionality allows for accurate assessment before any significant component replacements are made. After completing the necessary repairs, it's crucial to verify that the issues prompting DTC P0131 have been resolved. First, clear any stored DTCs using the diagnostic tool to reset the vehicle's monitoring system. Next, a comprehensive test drive should be performed to allow the vehicle's systems to recalibrate under real-world driving conditions. During the test drive, it is important to monitor engine performance closely, looking for any signs of the initial problems surfacing again. If the check engine light does not reacquire and the engine performs optimally across various RPMs and loads, it indicates successful resolution of the fault. This final verification step is key in confirming that the repair has been effective and that the vehicle is operating as intended. Implementing preventive maintenance can significantly reduce the likelihood of DTC P0131 and ensure the longevity of the AF sensor and the engine's performance. Regular inspections of the AF sensor and its connections can help identify any issues before they escalate. Additionally, maintaining the integrity of the wiring harness and shielded circuits can prevent external factors such as water intrusion or fraying that may lead to shorts or opens in the system. Monitoring fuel efficiency consistently can also reveal underlying issues, allowing for timely diagnosis. Generally, a proactive approach to maintenance minimizes the risk of malfunction and ensures optimal performance of your Honda Civic. In summary, understanding the air-fuel ratio, AF, sensor's critical role in engine management is vital for addressing DTC P0131. The troubleshooting steps outlined provide a structured approach to identify and rectify faults associated with low voltage readings. By examining the sensor, inspecting wiring connections, and evaluating the PCM, technicians can accurately diagnose issues and implement effective repairs. Furthermore, adopting preventive maintenance practices like regular inspections and constant monitoring contributes to sustaining peak engine performance. Keeping these factors in mind is essential, not only for achieving immediate repair success, but also for ensuring the ongoing reliability of your Honda Civic. Please like and subscribe to the channel. See you next time.